Hello, today we're going to talk about the trigonometric ratios finding missing angles, and we're going to use inverse trig ratios to find missing angles. So we start out by talking about operations and their inverse. The inverse of adding is subtracting, so they undo each other. Multiply and divide undo each other as well, so they are inverses. Raising something to the second power and then square rooting are inverses. And then we have the trig ratios sine, cosine, and tangent. The way we undo those are by taking the inverse sine, inverse cosine, and inverse tangent. This is used when we want to find angles. The first example is showing how to do the inverse of different problems. So when we have x plus 1, the way you get x by itself is to subtract 1 from both sides. Okay. Similarly, when you multiply by 2, you divide both sides by 2. Square rooting both sides to get rid of the square. And that's how you find different, how you isolate x in different circumstances. Now, when we have a trig ratio, so for example, sine of x, in this case, the only way to get x by itself is to take the inverse sine. In order to cancel the sine, we take the inverse sine of both sides. So inverse sine and sine cancel out, and you get x by itself. Inverse sine of 0.5, you do that on your calculator in degree mode, gives you 30 degrees. Same thing for cosine of x, but you apply the inverse cosine on both sides. Do that on the calculator, you get 60 degrees. And then same thing for tangent, inverse tangent, inverse tangent. Okay, so if you want to separate the angle from the trig ratio, you do the inverse. All right, so you use inverse trig ratios when finding angles. Second example, find the missing angle from the picture. So in this picture, we have the angle is up here, x, and we label opposite, adjacent, and hypotenuse. We figure out that we want to use the opposite and the hypotenuse because those are the numbers that they give us. Opposite and hypotenuse is sine. I remember from SOHCAHTOA, right? SOH means sine is the opposite over the hypotenuse. So the opposite is 23 and the hypotenuse is 28. Therefore, we put 23 over 28. Opposite over hypotenuse. And then to get x by itself, we're going to do what we call the inverse sine. Inverse sine of both sides. You get x equals, you type this into the calculator, 55.2 degrees. All right. Letter B, same thing. You're going to do label the triangle. And then in this case, we have opposite over adjacent, which is the tangent of 14 over 29. Inverse tangent of both sides. Use the calculator, and you get 25.2. Last example, the hypotenuse is up here. That's the longest side. And we get the adjacent. So adjacent and hypotenuse, we're going to use cosine equals adjacent over hypotenuse. 4.4 over 11. Inverse cosine of both sides, you get theta equals 66.2.